Hi, finite math people. This is our third lecture in logic and probably the last of our introductory lectures in logic. We've been talking about statements, simple statements, compound statements. We've been talking about negations. We've been talking about connectives. And today we're going to introduce two new connectives. And I think this is going to be the last of our connectives for quite a while. The first of the connectives has the form if ... then ... The form is if statement 1 is true, then statement 2 is true. That's the meaning. If statement 1 is true, then statement 2 will be true. That's what it means. And schematically or symbolically, we represent it as P, the first statement, and an arrow going left to right, and then the second statement. And I guess I might as well say this. This arrow has the connotation implies. So the symbolic form is P implies Q. In other words, statement P being true implies that statement Q is true also. So symbolically, this is the form of an if-then statement. And we read it this way. P implies Q, or if P is true, then Q is true. So we look at this and we say, if P, then Q. In other words, if P is Q, then Q is true. Or we look at this and say, P implies Q. Now, here's an example of the if-then connective joining two statements P and Q. And let's diagram this. If I pass all my courses, then I will graduate. So I pass all of my courses. That's going to be our P. And the statement, I will graduate, is going to be Q. And that's how we write it symbolically. The meaning is, passing all my courses implies I will graduate. Or, if it's true that I pass all of my courses, then it will be true that I graduate. If I pass all of my courses is true, then I will graduate will be true also. Now, let's follow up on this. We're not quite done with this example yet. Okay, still working on this example. This statement, if I pass all of my courses, then I will graduate, which we have diagrammed as P implies Q, or if P, then Q. This compound statement can be written symbolically as P implies Q, where P is the statement, I pass all of my courses, and Q is the statement, I will graduate. Let's look at another one of these. Okay, another example. Given the statements P, you will wash my car, and Q, I will pay you $10, write the statement if P, then Q in words. And notice that if we use P and Q in words, this means if P, then Q. In other words, if P is true, then Q is true. And we want to write that in words. So, if, and then the statement P, you will wash my car. So let's see, we have if P, and we need then Q. And Q is, I will pay you $10. So in English, here it is. And if we read it, it's correct, but it's awkward. If you will wash my car, then I will pay you $10. This is correct, but it did sound a little awkward, didn't it? If you will wash my car, then I will pay you $10. I don't think that's how most of us would say this. I think most of us would say this as, if you wash my car, then I will pay you $10. And so, for readability, I'm going to dispose of that word. And it brings up a good point. And that point is this. When we're joining simple statements together with connectives, we have a certain liberty of how we treat forms of the verb to be. Will, let's see. Okay, I'm going back about 50 years here. The 23 verbs of being. If, am, are, was, were, have, has, had, do, does, did, may, might, must, be, being, been, can, could, shall, should, will, would. I think that's is, am, are, was, were, have, has, had, do, does, did, may, might, must, be, being, been, can, could, shall, should, will, would. The 23 verbs of being, okay? And will is one of those. For readability, it's permissible either to omit or insert or alter one of the verbs of being or one or more of the verbs of being in the statement. Here for readability, we just omitted this word. So when we join two words together when we join two statements together with connectives, for the sake of readability, it's allowable to alter the form of the verbs of being that are used. It's also allowable to insert a verb of being where necessary or desirable. It's also allowable to delete a verb of being, just for the sake of readability. The original form that we had here, if you will wash my car, then I will pay you $10. It was correct, but it didn't read very well. And we looked at this and we immediately said, you know what? Here's the troublemaker right here. No one would say, if you will wash my car. They would just say, if you wash my car. And so it was perfectly permissible to get rid of this verb of being for the sake of readability. And when we join two simple statements with connectives, oftentimes that's a liberty that we will be able to take just for the sake of readability. Okay, well that was one connective. And I guess before I introduce our second guest, our second connective, I need to say one more thing about this. The formal term for a statement of this form is called a conditional statement. And I guess it's called a conditional statement because in order for this statement to be true, this statement is going to be true if whenever P is Q, then Q is true. So this statement, now let's see. Let's see. This statement is true if whenever P is true, then Q is true. And so in order for P to be true, Q has to be true also. In order for this statement to be true, whenever P is true, Q has to be true also. So there's a condition under which this statement is true. I apologize, that's a poor explanation. I'll give a much better explanation. in about 3 or 4 lectures when it really matters. But we call this a conditional statement because there's a condition that has to be satisfied in order for this thing to be true. Now let's meet our second connective of the day. Back again. Our next guest on the show is the connective if and only if. And the form of this connective is statement 1, if and only if statement 2. Or P, if and only if Q. And the meaning is this. Statement 1 is true if and only if statement 2 is true. In symbolic form, we write it this way. And notice that the arrow goes both ways. Now before, in the conditional statement, the arrow just went from P to Q, which meant that if P was true, then Q was true. Well, the arrow goes both ways here. So what that means is, if P is true, then Q is true. And if Q is true, then P is true. In other words, if one of them's true, they both have to be true. If one of them's false, they both have to be false. We can't have one of these things being true and the other one being false without making the entire statement false. So let's see, we might read it this way. P is true if Q is true, and P is true only if Q is true. So if Q is true, P is true. And P is true only if Q is true. So not only is it true that if Q is true, then P is true, but the only time that P can be true is if Q is true. The bottom line is, what this means is, if one of these things is true, they both have to be true. If one of these things is false, they both have to be false. If we have one true and the other false, that makes the entire statement false. Now, let's look at an example. Okay, another example. Let P and Q be as follows. P is the statement, I will pay you $10. Q is the statement, you will wash my car. So write the statement P if and only if Q in words. And I might as well make a note here. P if and only if Q. Okay. So, P, I will pay you $10. Well, I have my P. Here's statement P. I will pay you $10. And then we need if and only if. Okay. If and only if. Okay. And that's my arrow going both ways. And then Q. You will wash my car. Okay, I will pay you $10 if and only if you will wash my car. There it is. Now, what do you think about what we've written? It's correct. P, if and only if Q, it's correct. But what about readability? Have we done this as well as we could do it as far as readability is concerned? Or do I need to change something? I will pay you $10 if and only if you will wash my car. I think most of us would say, I will pay you $10 if and only if you wash my car. This form of the verb to be, it's correct, but it sort of hampers readability. I think most of us would say, I will pay you $10 if and only if you wash my car. And with this example, I think we get the meaning. If you wash my car, I will pay you $10. And I will pay you $10 if you wash my car. So each one implies the other. If I pay you $10, then it is for a certainty that you washed my car. And if you wash my car, it is for a certainty that I will pay you $10. So if one of them's true, both of them's true. Ooh, what happens if one of them's false? Let's see. Suppose I'm not going to pay you $10. Then I don't expect you to wash my car either. And suppose you're not going to wash my car. Well, forget about it. I'm not going to pay you the $10. So let's see. If one of these things is false, the other thing is false. If one of these things is true, the other thing is true. So with an if and only if statement, in order for the statement, the entire statement to be true, both simple statements have to be true. Or both simple statements have to be false. If this is false, then the sense is that's going to be false too. If this is false, then that's going to be false too. So I guess the only time that an if and only if statement is not going to be true is if one of them's true and one of them's false. And it doesn't matter which one is true and which one's false. If one of them's true and it doesn't matter which one, and the other one is false, then all bets are off. This statement is false. But if both simple statements P and Q are true, then the whole statement is true. And if both simple statements Q and P are false, the whole statement is true again. The only time the statement is not true is when one of these guys is true and the other one's false. Now, there's a formal name for this, and I won't try to explain it right now. We'll deal a lot more with conditional and biconditional statements later in our treatment of logic. But I do want to introduce the formal term. Okay, a statement of the form P if and only if Q is called a biconditional statement. I won't try to explain this fully, but remember what a conditional statement looked like? A conditional statement looked like this, didn't it? The arrow going one way. So a biconditional statement, arrow going this way, arrow going that way, bi for two arrows, one going each way. So this is a conditional statement. It has an arrow going one way. This is a biconditional statement. It has an arrow going both ways. Hey, back again. And now we're going to talk about something that doesn't involve directly simple statements, compound statements. See, it doesn't involve connectives. It does involve negations, though, but it doesn't involve simple statements. It doesn't involve connectives. And this topic is quantifiers. It's related to the word quantity. And when we think of quantity, we think of how many or how much. And here are the common quantifiers: all, some, or none. Now, I guess I better say more than that. I better define this. A quantifier is a word that describes how many or how much common quantifiers. Common quantifiers are all, some, and none. And the thought just occurred to me, even though we're not going to be talking about connectives right now, and even though we're not going to be talking about simple statements or compound statements, we are in just a minute going to be talking about something that we talked about a little bit before, and I hadn't really foreseen the connection until just now. The connection between quantifiers and forms of the verb to be. And typically, we don't have a quantifier without a form of the verb to be. So let's put some of these together and consider what they mean and what they don't mean, and consider what the negations of these things are. Typically, when we use quantifiers in connection with the verb to be. For example, when we talk about all, we typically make some claim involving all. For example, all astronauts are pilots. Now, that may or may not be true, but when we use the quantifier all, what comes right after that? All such and such are pilots. All astronauts are pilots. Maybe that statement's true, maybe it's false, but typically when we use a quantifier, somewhere there has to be a form of the verb to be also. So the quantifier all goes with the verb are or perhaps do. And synonymous with the quantifier all is every. all astronauts are, or all astronauts do such and such. Every astronaut is, or every astronaut does such and such. So the meaning here is that all objects under consideration satisfy a given condition. In our example, all astronauts satisfy the condition that they are pilots. Or every astronaut satisfies the condition that he or she is a pilot. So with the quantifier all or every, what we're saying is that all objects under consideration satisfy a given condition, or every object under consideration satisfies a given condition. And, I guess I should make my verbs consistent with the rest of the sentence, huh? Okay. Now the quantifier some are, or some do. It means that some objects under consideration satisfy a given condition. Okay. Turns out it used to be the case that all astronauts were pilots, but that hasn't been true since the early space shuttle days. So now all we can say is some astronauts are pilots. Some objects satisfy the condition that they're pilots. Or at least one object under consideration satisfies the given condition. At least one astronaut is a pilot. They may not all be pilots, but at least one astronaut is a pilot. These two mean the same thing. Some astronauts are, at least one astronaut is. They mean the same thing. Some are, at least one is. They mean the same thing. If it's true that at least one object under consideration is, then we can truthfully say some of the objects under consideration are such and such. And then there's our last quantifier, none are, or none do. And I guess I'm going to have to add, just to make this I'm going to have to admit no are or no do. None are, or no such and such are. No astronauts are pilots. Well, I don't think that's true, but at any rate, what we're saying is none of the objects under consideration, not a single object under consideration, satisfies a given condition. Yeah, no objects under consideration. No astronauts are pilots. No objects under consideration satisfy the condition that they are pilots. I can write it in terms of this grammar as well. None of the astronauts or none of the objects under consideration satisfy a given condition. Now, you know what? I think we're going to have to look at a ton of examples here. I really do. So let's do the examples. Okay, some examples involving quantifiers. All smart people are rich. That means the same thing as every smart person is rich. Here's one that's not quite as obvious. Some pilots are astronauts. That's exactly the same thing as saying at least one pilot is an astronaut. If at least one pilot is an astronaut, then we can say some pilots are astronauts. And here's another one. No priests are stamp collectors. No priests are stamp collectors. That's the same as saying there does not exist a priest who collects stamps. Now that we've seen a few examples, let's figure out how it is that we negate each of these quantifiers. Okay, negating quantifiers. This is going to get good. When we negate a statement involving a quantifier, we ask ourselves this question: what must necessarily be true in order for the original statement to be false? And I guess if we're asking a question, then this statement would end in a question mark, wouldn't it? And in a perfect world, the question mark would appear outside the quote. But this world hasn't been a perfect world since I was born. So it was a perfect world before then, but it hasn't been a perfect world since. What must necessarily be true in order for the original statement to be false? Let's look at this example. All astronauts are pilots. Well, right away, I think we're going to come up with the thought, no astronaut is a pilot. And if this statement is true, then that one is definitely false. This statement being true will definitely make that statement false. But does this necessarily have to be true in order to make that false? In order for the statement, all astronauts are pilots, to be false, is it necessary that not even one astronaut is a pilot? Maybe not. What about this? If at least one astronaut is not a pilot, then the original statement is false. And think about this. If at least one astronaut, if it's not true that at least one astronaut is not a pilot, then that means all astronauts are pilots, and this statement is true. So in order for the original statement to be false, it's necessary that at least one astronaut is not a pilot. So it's not necessary that no astronauts are pilots. No astronaut is or no astronauts are pilots. It's not necessary that no astronaut is a pilot or that no astronauts are pilots to make this false. It's only necessary that at least one astronaut is not a pilot to make this statement false. So, let's look at the negation of all. These are equivalent. All astronauts are, every astronaut is, they're equivalent. Now let's look at the negation. The negation was at least one is not. Okay. Now, an equivalent way of saying at least one is not is some are not. If it's true that at least one is not, then we can truthfully say some are not. And I guess there's also one more way that we can actually do this, although this is not nearly as common. At least one is not the same as saying there exists one. That is, oh no, I'm going to have to redo my box. Well, we have another kid on the way, so we're going to add another room to the house. There, how about that? These are the ways to negate all are or every is. And the rule of thumb that we used was what absolutely has to be true to make the original statement false. To make the statement all are false, all we have to show is that at least one is not, or some are not, or there exists one that is not. Now, just for the sake of getting the most bang out of our buck, is this a two-way street? In other words, if these three statements are negations of these two, is it also true that these two statements are the negation of these three? And the answer is absolutely yes. At least one astronaut is not a pilot. Well, how do we negate that? What absolutely has to be false, What absolutely has to be true in order to make the statement, at least one astronaut is not a pilot? All astronauts are pilots. That's what has to be true. Or, some smart people are not rich. What absolutely has to be true to make this false? Every smart person is rich. Okay, well, every smart person is rich. I guess I'm not smart. Or not smart enough anyway. But the negations go hand in hand. If this is the negation of something over here, then everything over here is the negation of each statement over here. It's a two-way street. So let's see. We've considered the negation of all are or everyone is. I guess now we have to look at the quantifiers some are or at least one is, or there exists one that is. Okay, now we're going to negate the quantifier some are or some do, and just consider the statement, some women play golf. What about the negation of that? Well, our initial reaction might be, some women do not play golf. And let's think about that for a minute. Does this statement being true in any way make this statement being false, or make this statement be false? See, it is a fact that some women play golf and some women don't play golf, which means that these two statements are both true simultaneously. This statement being true does not make that statement false. And this statement true does not make that statement false. The fact of the matter is, some women play golf, some don't. Both are true simultaneously. And the fact that one statement is true does not make the other statement false. So, our initial thought on this matter turned out not to be correct. This is not the negation. What would have to be true in order to make this false? Let's see, some women play golf, which means there's at least one woman somewhere who plays golf. What would have to be true in order to make this statement false? What do you think? Another way of saying this is at least one woman plays golf. At least one woman plays golf. Well, the only way that could be false is if what? No women played golf, right? Well, let's see, that's going to be bad news for married couples who play in doubles tournaments on Sunday afternoons. Bad news for golf courses too. I guess they're just going to have to scrap all their Sunday afternoon tournaments. Now, if this were true, that would be the case. But in order to make this statement false, this statement has to be true. Some women play golf. What is necessarily true in order to make this statement false? No women play golf. Okay, so now let's look at the negation of some do. And apparently the negation of some do is none do, or not a single one does. But let's look at it closely. Let's see, we found out that the negation of some are is that no are or none are. None are, no are, none do. Now, is there another way that we can say some are? I think for the sake of our example, we said saying some women play golf is the same as saying there exists a woman who plays golf, or at least one woman plays golf. So some are, at least one does or is. There exists one that does or is. The negation of all of these three, since they all mean the same, the negation of all of these three is none are. There does not exist one that does. And this is a negation. Is it a two-way street? You bet it is. So the negation of no women play golf is some women do play golf. So we have to be careful again, don't we? The negation of no women play golf is not all women play golf. The negation of no women play golf is some women do play golf. One more quantifier to look at. Okay, let's look at this. Consider the statement, no men wear polka dot underwear. Now, there are two ways to approach this, but we'll approach this without thinking things through first and say, okay, the negation is all men wear polka dot underwear. And that's our initial reaction. It's usually most people's reaction. when they try to negate the quantifier no or none. None do, all do. And it turns out, let's see, do all men have to wear polka dot underwear in order for this statement to be false? I hope not. What absolutely necessarily has to be true to make this statement false? Is it necessarily the case that all men have to wear polka dot underwear to make this false? Isn't it true that this statement will be false if there's even one man that wears polka dot underwear? So this is not the negation. This is. The negation of none do is at least one does. And you know what? We could have done this a different way. Let's see. Saying at least one does is the same as saying some do, right? So this is the same as some men do wear polka dot underwear. And see, there's another way that we could have done this example. Because earlier on, we found out that the negation of some do, or at least one does, is that none do. Yeah. See, we've already figured out what the negation of some do, or at least one does, is. The negation of some do is that none do, or that does not exist one that does. So we've already seen this. It didn't occur to us right off the bat that we'd already seen this, but we have already seen it. So this pretty much exhausts all the cases for negating quantifiers. So I guess the thing to do now is just do a bunch of examples. You were looking forward to that, weren't you? Okay, first example. Negate each of the following statements below. Some butterflies migrate. How do we negate some are or some do? None do, right? Okay. The negation is none do, or none. No butterflies migrate. And we can say there does not exist a butterfly that migrates, although this is rare. Either of these are acceptable. The more common negation would just be to say no butterflies migrate. But either one is acceptable. Okay, no guitarists play bass. Now, the negation. How do we negate none do or none are? See, the negation of none do or none are or no such and such do is some do or at least one does, right? So the negation of no guitarist play is that some guitarists play bass. And we would also say at least one guitarist plays bass. And we can even say there exists a guitarist that plays bass. We got to do more than just two examples, don't we? I'll say, all limes have seeds. What's the negation of all do? Or everyone does. Every lime has seeds. All limes have seeds. What's the negation of that? Isn't it some do not, or there exists one that does not? So both of these are negations of all limes have seeds. Some limes do not have seeds. At least one lime does not have seeds. Okay, we're cooking here. Let's do some more. Okay, every sentence is a question. What do you think about this? On closer inspection, this is pretty much just number 3 in disguise, isn't it? Every sentence is a question. Could easily be rendered all sentences are questions. So we negate number 4 the same way we negate number 3. So here's the negation. So if everyone is or all are, the negation is some do not or some are not. Some sentences are not questions. Or we could say, at least one sentence is not a question. And we could say also, there exists a sentence that is not a question. The most common rendering would be this. And considering how we've done number 4, maybe we can take a peek back at number 3 and see if we could have done number 3 a different way. We're done with 4. But number 3, see, we could have done it this way also, right? There exists a lime that does not have seeds. Yep, this would be fine also. New exercise. No limes have seeds. Okay. Well, let's see. What absolutely has to be true in order to make this false? At least one lime does have seeds. So the negation of none do is that at least one does not. Let's see. The negation of none do is at least one does. There we go. The negation of none do, at least one does. Or, what's another way of saying at least one does? See, what's another way of saying at least one does? Some do, right? Okay. And we could say also, there exists a lime that has seeds. Now, of these three, this would definitely be the most common rendering. Okay, I guess that's enough examples for now. It's about time I gave you folks some homework, and I will do that shortly.